It says, given the universal set U, which is equal to A, B, C, D, E, and set A is equal to BC, and set B is equal to BCE, find each of the following sets. Could you draw, let's think about this for a second. Could we draw a Venn diagram given, well, we can. I want us to draw a Venn diagram with this information. Okay? We know the universal set has those letters, A, B, C, D, and E. So, just quickly, because I know we're going to have some of these where we're going to have to draw out set A, set B. One thing that you want to look at whenever you have those sets merging together. What's in the middle here? Okay? That's what A and B, sets A and B have in common. So what do they have in common? B and C. So set A has BC, which we have that. Set B has BC, but we also have what else? E. What will be on the outside of this? A and D. So example A, because sometimes it might be easier to draw the Venn diagram, but you can look at the information and also find what's needed to answer the question. So it says here, example A, we have A union B complement, or we can say prime. First of all, A union B, isn't that everything? Well, B, C, and E. But then it says, what is not in A union B? It will be A and D. This is what this is saying, okay? That word not, or prime. So we would say A and D. Letter B. A prime intersects B prime. So when we think about it, you're saying, okay, what's not in A? A and D. What's not in B? A and D, right? Okay. So then you're saying A and D intersects A and D. Intersect means what do they have in common? A and D. Well, let's do this. A prime, let me draw this out. What's not in A, because I heard A and D twice. Hold on. What's not in A? E, right? Let's do this. A, D. I'm going to write this a little bit better. A, D, and E. That is not in A, right? We all agree. What's not in B? A and D. Now, we have A prime, B prime. Now we want to intersect those, and then with that intersection, what do we have in common? A and D. There we go. We got it. Last example of this particular section 2.3. Any questions so far? Not too bad? Example 8. According to factmonster.com, that should be monster, I believe. That's me typing very, fast. Among the U.S. presidents in the White House, 26 had dogs, 11 had cats, and 9 had both dogs and cats. How many U.S. presidents had dogs or cats in the White House? Well, to determine the number of dogs or cats in the White House, we're going to be using the cardinal number of the union of two finite sets. This is the formula that we're going to be using. Okay? A union B is equal to. Okay? So what will represent our A here? The dogs. So we have, 26 plus, we're looking at the number of cats, minus, what do we have? A intersects B. We had 9 both, had both dogs and cats. All right, so the number of elements of A or B is equal to the number of elements of A plus the number of elements of B minus, and then we have the number of elements of A intersect B. So what's our answer here? 20 what now? 28, yes. Who remembers cardinality? We talked about that. It was part of the, and we can go back to that page number. Let's see. Page 6 of your notes. The cardinal number of a set A. Okay, the element of A is the number of distinct elements in set A. We're talking about numbers. Just kind of refresh from last Thursday's notes. So, for example, this is my key here. We have set A equals to 6, 10, 14, 15, and 16. How many distinct elements? We have a total of 5. How many elements are in or between the braces here? 5. So when we're talking about cardinality, we're talking about, of course, the actual elements, the number of elements we have in that set. So set A has 26, we represented the dog. Set B has, we're representing that with cats, which is 11, and then we're talking about both. So yes, we're going to be using this formula to find the cardinal number of the union of two finite sets. Any questions?